Annie is working on the multiplication problem 19 times 21, and she says that 19 times 21 should equal 20 times 20 because 19 is 1 less than 20 and 21 is 1 more than 20. This is a wonderful idea, but is incorrect. If not, use the diagram below to help you explain why not. And it tells us here that there's 20 rows of dots with 21 dots in each row. So this idea, it kind of makes a lot of sense. I think if this were addition, it'd be very clear, like, yeah, if I'm adding 19 and 21, that would be the same thing as 20 plus 20, because I'm essentially taking one away from one and giving it to the other, right? But then this idea of, does that work with multiplication, right? With 19 times 21, can I say that that's the same thing as 20 times 20? So let's start with what it is that we are trying to find. So we're trying to find 19 times 21. So if I look at my figure and kind of outline that, and I'm just gonna like box it in here. So I'm gonna do 19 rows times 21 in each row. And so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I'm going to use all 21 items in each row. And then I'm going to do 19 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So all but that last row, right? And that makes sense. They said there were 20 rows, so I'm just not going to use the last one. I'm just going to outline in red what this would look like. So this part that I'm outlining in red is my 19 by 21 array. And that's what I'm trying to find, right? That's the original problem that we're starting with that Annie is trying to do. She's trying to do 19 times 21, which is not an easy one to do in your head. We're trying to find area of the red 19 by 21 array. And we can see from what we've outlined here, this includes all of the dots in the figure, except for the last row. That last row has 21 dots in it, all right? So except for the last row of 21 dots. So then her idea then is she wants to say, well, can I just do 20 by 20, right? Can I just say that's going to give me the same thing as a 20 by 20 array? So let's outline that one. So 20 rows, and I'm going to use blue. So 20 rows would be all of the rows. But now I'm doing, instead of 21 dots in each row, I'm only doing 20 dots in each row. So that means when I outline this, I'm gonna include all the rows, but I'm not gonna include all the columns. I'm gonna exclude that last column. So far this looks like a nice idea, right? It's like, well, going one way, I'm including all but one of the rows. Going the other way, I'm including all but one of the columns. So if I'm finding the 20 by 20 blue array, we can see this includes, again, all of the dots on the figure, except for the last column. And that last column has how many in it? Well, this went all the way to 20. So, because it's 19 going to the red, but then 20, right? This is a 20 by 20 for the blue. So that means that there's 20 items, 20 rows. So that means that last column is 20 dots. And you could count that if you want, right? So we're talking about what's being excluded from the blue, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 that are being excluded from the blue array. So if I really look at this, this is a good idea, but it's not quite right? So like, in order to be the same number, right? In order for 19 by 21 to give me the same number of dots or the same answer as 20 by 20, they'd have to contain the same number of dots. Now, I really don't want to have to go through and count all the dots, but I can look at what dots are being excluded, right? So if the 19 by 21 array includes all of the dots except for, we said 21 of them, and the blue array so the 20 by 20, right? Includes all the dots except we said 20 of them, right? Then that means that they can't equal the same number of dots. Because if they were going to include the same number of dots, that means they'd also have to exclude the same number of dots, and they don't, right? And actually, what they don't is this one right down here, right? This dot isn't being included by either, right? So, like, when you go with the red direction, you're excluding 21 dots, including that black one down at the bottom. When you go with the blue direction, you're excluding 20 and including that one at the bottom, right? So like you have this difference of one dot. So, what's the idea? What's going on? What's the math behind this? So the idea was we were starting with 19 times 21, right? That's what we were trying to find, right? And she's trying to find like a mental math strategy for doing that. And so really what's going on there is we're saying, okay, she wanted to use 20 because 20 is easier, right? So that's kind of like saying, okay, I'm going to take 19 and say, well, that's really 20 minus 1, right? Rewrite it using 20, and then also rewrite the 21 using the number 20. So that would be 20 plus 1, right? And this is kind of the idea that Annie was doing. She's like, okay, well, since, 19 is 1 less than 20 and 21 is 1 more, let me just rewrite it using 20, right? But if I were to actually use the distributive property here and go through this process, so 20 times 20 would absolutely give me 400, right? But then you are missing these other parts, right? So if I were to do FOIL method of first, outer, inner, last, 20 times 1 would be a positive 20. Negative 1 times 20, when I do the inner terms, would be a negative 20. And that's fine because those cancel, right? Those cancel out. So like when you exclude these, right, you're going to also exclude them when you exclude them from the other rectangle, right? From the red rectangle. So it's okay that you've got plus 20, minus 20 because they cancel, but what you're missing is the last term. So negative 1 times 1 is minus 1. And so, this part positive 20 minus 20, that's just 0. But the answer is not 400. The answer would actually be 399 because of this 1, right? This 1 that you need to subtract off, right? Because you have not counted that with either.